Okay, good afternoon, girls. So today we'll be starting solution of triangles. So in this, we are going to. This is one of the most important topic for IIT JEE because statistically speaking, almost every year, 2 years of questions come. Two questions comes from every year. So and if you are not this chapter is actually a very easy chapter, but the questions turns out to be a difficult if you are not if you haven't finished this chapter. So this chapter basically talks about triangles and various relations. So we'll just see and we'll derive some properties, and we have to remember those properties. There are basically 27 properties. I have tried to arrange them in an order how they are getting. So I've made them questions out of it. Okay. And then we'll be studying how these things are coming up, right? So before we start it, we must understand what is a triangle. So what is the definition of a triangle? Basically, triangle is a polygon with three sides, right? Now, when we talk about triangle, we have various parts of triangles like medians. We have altitudes. We have perpendicular bisectors, right? We have angle bisectors. Now we know all these four things are concurrent, right? So the point of concurrency of medians is called centroid, and the point of concurrency of the altitude is called also center, and the point of concurrency of angle bisectors is called in center. And what is x center? When exterior angle bisectors where they meet, right? That is x center. And then we have the circumcenter. Basically, that is the point of concurrency of the perpendicular bisector. I hope everybody knows what is a median. I hope everybody knows what is angle bisector. I hope everybody knows what is altitude, and everybody knows what is perpendicular bisector, right? Okay. So some of the symbols which we are going to see, I'm just going to we'll be getting friendly to the terms and symbols and notation first. Let's say this is my triangle ABC. Okay, these are the symbols which we are going to use. Here we will be using delta will stand for the area of the triangle, okay? Delta will stand for the area of triangle. A would stand for this angle A and the vertex as well. And this would be angle B and this would be angle C. The sides A, B, C opposite to the angle. This would be A, this would be B, and this would be C, small a, B, C. Now R would be called as in center, in radius. So if you see, this is basically angle bisector. This is your another angle bisector. This point of concurrency is called in center. So I'm going to draw in circle here. So this is basically your in circle, and you have this is your in center, and this is perpendicular distance. So basically, these three sides turns out to be the three tangents, right? Now this distance, this radius is going to be called as in center, right? Now if you observe, basically, you can have more circles which are actually, if you see, if I'm going to draw a circle which has this and this line has a tangent, that would be the x circle, right? Similarly, you will have something like this and something like this. So you have this three circles. So these three circles are basically x circles. जो कहाँ से मिला है मुझे? Right. So this one will be called I1, this would be called I2, and this would be called I3, and this would be called I. Okay. Now this radius is going to be called as R2. This radius is going to be called as R1, and this radius is going to be called as R3, right? Or RA, RB, RC. Okay. Now the point of concurrency of the altitude is going to be called as orthocenter. We will be denoting by H. Okay. And if I have a triangle, if I have a circle which is circumscribing this triangle, so I'm going to call this circle as circumcircle, and the radius is going to be called as circumradius, right? And see, orthocenter will be denoted by H, not O. Remember that. Orthocenter will be denoted by H, and circumcenter will be denoted by O, and centroid will be denoted by G. Okay. So these are the symbols which we are going to. So I just got you familiarized with the symbols which we used. So we won't be every time saying in center. We'll just be using the short form, right? So everybody knows this and quite familiar with this, right? Now the first property which we are going to prove is show that the in radius is actually equal to area of triangle upon semi-perimeter. S would be called as semi-perimeter. What is S? A plus B plus C by 2. And you should remember S minus A would be B plus C minus A by 2, and S minus B would be A plus C minus B by 2, and S minus C would be, okay. Now coming to the first property, the first property says, the property number 1 says, the in radius is actually area of triangle upon semi-perimeter. Now how we are going to prove it? Can you prove it? You've already proved this property in class 9th, if you remember. How? See, this is a triangle, right? This is your in circle. Clear? Now this is going to be your in center. I can split. The big triangle has been divided in 3 triangles. And I know this is 90, this is 90, and this is 90. And I know this is R, R, R. So what will be the area of these 3 smaller triangles? Half RA plus half, that would be equal to, so R would be equal to, clear? So the first property is very clear. No issue with this? Now this going to the second property, I say show that RA is equal to delta by S minus A. Since this triangle is basically cyclic in nature, so I can say RB would also be equal to right. Now the question is RA, RB, RC. These are my X radius. Now we must prove that the Rx radius is basically area of the triangle upon S minus A. So how to prove it? So let's first draw the diagram. Now observe this triangle. Can you see this triangle? This would be, this is B, this is C, and this is A, right? What would be the area of this triangle? This is my base, and this would be my height, right? This is 90 degree RA. So can I say the area of this shaded would be half RAB? Can I say the area of this shaded triangle, the obtuse triangle, would be, see, this is your base, the height would be this, right? It's basically an obtuse angle triangle. So that's why you have a height outside, right? So I can say the area of this shaded triangle is, and similarly I can say the area of this would be half RAC. Okay, now can I say the area of triangle would be equal to the area of this plus this minus this? And what would be the area of this one? What would the area of this one? Half RAA. So this area is half RAA. So can I say delta is basically half RAC plus half RAB minus half RAA? Can I say this? So can I say this, that delta is basically RA into B plus C minus A by 2? So can I say RA is going to be delta by S minus A? And similarly, I can say RB going to be delta by S minus B, and RC is going to be delta by C. Cyclic in nature. एक proof कर दिया, all the three is proved, right? Clear or not clear? So we have got two very important properties. One was R is nothing but delta by S, and RA is nothing but delta by S minus A. RB is nothing but delta by S minus B, and RC is nothing but delta by S minus C. Now coming to the third property. Show that this is your property 3. देखो सारी properties को हम prove करेंगे, तो मैंने सारी properties को questions की तरह लिख दिया है. Okay, show that 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R, where R1, R2, R3 is your x radius and R is your in radius. Now you have to prove this expression. Now how to prove this? Simple, using the property 1 and 2. We know R1 can be replaced by, so I can say S minus A by delta plus S minus B by delta plus S minus C by delta is equal to S by delta. Is it true? Is it true? देखो लेफ्ट हैंड साइड में है ना, डेल्टा कैन बी कैंसल्ड आउट. लेफ्ट हैंड साइड में बचेगा 3s minus a plus b plus c is equal to s. So 3s, right? Clear? So the third property is also clear. 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equal to 1 upon R. No issue with this? Okay. So property 1, देखो इसे याद रखना बहुत जरूरी है, that is why. लेकिन मैंने इसको ऑर्डर में रखा है तो so that it makes sense, इसको प्रूव करना मुश्किल ना पड़े. So the property 1 says R is delta by S, property 2 says RA is delta by S minus A, and similarly RB, RC, and then you have 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equal to 1 by R, and that's very easy to prove, right? Now coming to the fourth property. The fourth property says R1, R2, R3 is equal to delta S. How to go for this? करो prove. Very easy to prove. हो गया? ये ना left hand side. So I can multiply and divide by S. So I got S delta cube by delta square. है ना? So I can say clear, easy. The fifth property is R, R1, R2, R3. बताओ क्या होगा equal to? Obviously, I know this is delta S. And what is R? Delta by S. See? So 5 properties are very easy. Do the sixth one. बताओ क्या होगा इसका equal? R1, R2 plus R2, R3 plus R3, R1 would be equal to? You see, they're multiplying in a pair, right? R1, R2, R2, R3, R3, R1, R3. क्या करें हम? इसको ऐसे लिख दो. हो गया? क्या कॉमन आ गया? अंदर क्या रह गया? ये क्या है? डेल्टा एस. ये क्या है? क्या हो गया? Clear? Easy? So ये सारी properties, 6 properties is making sense now. ठीक है? कोई भी ऐसे out of the blue नहीं आ रहा है और सबका proof आपको पता है. अब बताओ area of triangle कैसे निकालते हैं? If I call this is my area of triangle. This is my triangle. How to find the area of triangle? हाँ? बेसिक जो हमने क्लास 6 में किया था, हाफ इंटू बेस इंटू हाइट. तो हाफ इंटू बेस इंटू हाइट क्या होता है? ये हो गया तुम्हारा हाइट. If I call this is angle B, so what is height is going to be? C sine B. So the delta is going to be half AC sine B. Since it is a cyclic in nature, I can say half is equal to half, right? Clear? Sanmaya? So the area of triangle is half AC sine B, half BC sine A, and half AB sine C. Now we are actually going to the most important property. Now we are going to the most important property called sine rule. Sine rule. अब इसी से हम sine rule निकालते हैं. कैसे? I know this three equations, right? So I can cut off this. So I have AC sine B, BC sine A, and so I can say if I divide all the three thing by ABC, what will get? Sine A by A is equal to sine B by B is equal to sine C by C. इसे हम A by sine A भी लिखते हैं. A by sine A is equal to B by sine B is equal to, this was the next most important property. It was property 8, right? This is called sine rule. सबसे important है ये. Here is the next slide. Now the question is, the ninth property, which is the extension of this property only, is it equal to something? What is that? K. What is K? क्या होता है वो कांस्टेंट? हम लोग डिस्कस कर चुके हैं सब. साइन रूल तो मैंने बहुत बार डिस्कस किया है. So the property 9 is basically A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R, where R is, इसे प्रूफ किया कभी? नहीं, चलो कर देते हैं. ये सब क्लास 10th की चीजें हैं. This is your triangle ABC, and that is your circumcircle, right? Right. And let's say this is your circumcenter. So this is your diameter, right? Right. Now join this. दिख रहा है ये blue side वाला triangle? This is angle A. So this would be angle A. What would be, if this is your diameter, what would be this angle? 90, right? ये A समझ में आ रहा है ना? Described angles on the same side. Now this is your right angle triangle. This is your 2R, right? This is your circumdiameter 2R, and this is your A, ना? तो क्या होगा ये? This would be 2R cos A, and this would be, so what is A by sine A? 2R. What is B by sine B? 2R. And C by sine C? 2R. Understood? सब क्या क्लास 9 10 की चीजें है ना? समझ में आया ये कि नहीं आया? समझ में आ गया? Now you have this IIT JEE question. There was A square plus B square sine A minus B is equal to a square minus b square sine a plus b. Show that triangle ABC is either isosceles or right angle triangle. देखो साइन रूल की प्रॉपर्टी, क्वेश्चन साइन रूल तो आप समझते हो. नाउ द क्वेश्चन इज व्हेन टू यूज साइन रूल. मैंने बताया था ना व्हेन टू यूज साइन रूल. व्हेन टू यूज साइन रूल, बेसिकली व्हेन वी शुड यूज साइन रूल, whenever we are dealing with the sides. When we are dealing with angle, we have to deal with cosine rule. When we have to deal with the sides, we will handle with sine rule. Now, since on the left hand side I have sides and angle combination, again on the right side I have sides and angle combination, so I can get rid of my sides. I can get rid of my sides. How to get rid of my sides? A square plus b square को हटा दो by 4r square sine square a plus sine square b into sine a minus b is equal to 4r square sine square a minus sine square b upon sine a plus b, right? यही था ना? कोई प्रॉब्लम नहीं है? बट द क्वेश्चन इज, ये गया, ये गया. अच्छा देखो, आप लोगों ने ट्रिग्नोमेट्री चैप्टर पढ़ा है, उसमें ये वाला पढ़ा था, साइन ए प्लस बी इंटू साइन ए माइनस बी क्या होता है? साइन स्क्वायर ए. सबको प्रूफ पता है? हाँ, एनीवन नॉट हैविंग दिस, पहली बार देख रहे हो ये थ्योरम, ये आइडेंटिटी, या यू डोंट नो द प्रूफ ऑफ इट? Everybody knows the proof of it? Just open it up, sine a plus b, sine a minus b, and you will get the a square minus b square form, right? So, same way, you also know what is cos a plus b into cos a minus b? What is it? Cos square a minus sine square b. ये भी पता है how to prove it? Now the third question is, जब भी ट्रायंगल की बात हो रही है ABC की, है ना, जब ट्रायंगल में हो तुम ABC, तो you know A, B and C. साइन ए को समझ में आता है साइन ए है, साइन बी भी समझ में आता है साइन बी है, साइन सी कैन ऑल्सो बी रिटन एज साइन ए प्लस बी. ये बात पता है ना? पक्का? ओके. नाउ कमिंग टू दिस, सो आई कैन से साइन स्क्वायर ए प्लस साइन स्क्वायर बी इंटू साइन ए माइनस बी इज इक्वल टू sine a plus b into sine a minus b into sine a plus b, right? Can we cut this two off? नहीं, एक इक्वेशन बनेगा ना. So we can say sine a minus b is equal to 0 or sine square a plus sine square b is equal to sine square a plus b. इसका मतलब क्या हुआ? इसका मतलब हुआ a and b are equal angles. इसका मतलब क्या हुआ? Isosceles triangle. So first part clear. Now sine square a plus sine square b is equal to sine square a plus b, which I can write it as sine square a plus sine square b is equal to sine square c. इससे क्या पता चला? Pythagoras theorem. So either Pythagoras theorem is true or they are isosceles. So hence proved. It was an IIT JEE question. Okay. So what is the idea behind that? You have to see the sides, and you have to get, whenever you see the sides, you can use the sine rule, right? Can you come down? Now you see another IIT JEE question. The question is, it says tan of b minus c by 2 is equal to b minus c upon b plus c cot a by 2. Okay, now how to go for it? Again, we'll get rid of this. So I can say, ये proof करना था. This is an ITJ question. So I can say sine b minus sine c upon sine b plus sine c is equal to into cot a by 2. कह सकता हूँ मैं? Now what is sine c minus sine d? Sine c minus sine d. 2 into sine c minus d by 2 into cos c plus d by 2. So on the above thing, sine b minus c by 2 into cos b plus c by 2. और नीचे 2 into sine b plus c by 2 into cos b minus c by 2 into cot a by 2. Right? So this gone, this gone. ये सेफली आ गया tan b minus c by 2. इसको छेड़ो मत, इसको अलग छोड़ दो. Into ये आ गया ना. What you got is cot b plus c by 2 into cot a by 2, which I can write it as pi by 2 minus a by 2. And what is cot pi by 2 minus a by 2? Tan a by 2. So I can say tan a by 2 into cot a by 2. So eventually this will go off. So left side equal to right side. समझ में आया? नहीं समझ में आया? Okay. So very easy question, right? Basic concept of sine rule, and you are there. मतलब इस triangles के questions पे solve करते टाइम दो चीज बड़ा important ध्यान रखना. C can easily be converted in a plus b and in sine form और cos form में minus के साथ, right? और pi by 2 minus a plus b by 2, ये दोनों forms को दिमाग में रखना होता है. Clear? Do the third question. The question says the circumradius is the circumradius is 10 and a is 5. Capital R is 10 and a is 5. Find triangle area by BC. बताओ जल्दी से. 2 minutes. Solve it. Which questions again, sir? Ask question number. What the answer? How to go for it? क्या रहा है? 10. क्यों? I know area of triangle is half BC sine A, right? 1 by 8 I think is the right answer. So sine A would be equal to 2 into triangle by BC. Okay. Now actually I have to find half of sine A is equal to triangle BC. Now how to find half sine A? I know A is equal to 2R sine A. So sine A is basically 5 by 20. So half would be 5 by 41 by 8. Right? You know sine A is 5 by 20. So half sine A would be 5 by 40. That is 1 by 8. Right? Easy question. See in the previous question, It was tan b minus c by 2 is equal to b minus c upon b plus c into cot a by 2. So what I did, I simply applied the sine rule because I saw the sides, I saw angle side is something which is disturbing the equation. So using the sine rule, I made it 2r sine b minus 2r sine c upon 2r sine b plus 2r sine c into cot a by 2. I got rid of 2r and I simply wrote it sine b minus sine c upon sine b plus sine c into cot a by 2, which eventually gave me 2 into sine b minus c by 2 into cos b plus c by 2 upon 2 into sine b plus c by 2 into cos b minus c by 2 into cot a by 2, which eventually gave me 2 cancel, and it gave me tan into b minus c by 2, which was on my left side. So what I did, I just left it alone and I manipulated this thing, and I write this is cot b plus c by 2 into cot a by 2. So b plus c by 2 can easily be written as pi by 2 minus a by 2 into cot a by 2. So cot pi by 2 minus a by 2 turned out to be tan a by 2 into cot a by 2, which eventually gave me 1. So 1 into tan b minus c by 2 on the right side, and left side tan b minus c by 2, and hence it was proved. Next page. Now you have to prove, this is your 10th property. Property number 10, it says a cos b plus b cos a is equal to c. Okay, ये प्रॉपर्टी इसे हम प्रोजेक्शन फॉर्मूला भी कहते हैं. Okay, the simple how to prove it? Simple projection से ही prove हो जाएगा. So just draw this. Just let this C, A, B. So this is C, this is B, this is A, right? So this is A, this is B, this is 90. So I can say this length is A cos B, and I can say this length is B cos A. So I can say B cos A plus A cos B is equal to C. Very easy. We call it projection formula. That is property number 10. कोई problem इसमें? No? No. Property 11 is basically altitude formula, which says this is your altitude, right? So what he says that B sine A would be equal to A sine B. Actually ये sine rule ही है, portion of sine rule. क्योंकि I know sine A by A is equal to sine B by B, right? So basically projection ये sine rule का ही portion है. So you understood? This is altitude formula, and this is your projection formula. Clear? So I can say A cos B plus B cos A is equal to C, and I can say B sine A is equal to A sine B. ये तो sine rule से ही आ रहा है. Done? Now the 12th property says R is equal to ABC by 4 delta. How to prove this? Simple delta से start कर दो. Delta is half, which you can easily write it as sine A can be easily written as A is basically 2r sin A, so sin is A by 2r. हो गया. Right? Clear or not clear? So these properties are very easy, right? है ना? सारी चीजें सेंस बना रही है और बहुत आसानी से हो रही है. बस दिमाग में थोड़ा रखने में प्रॉब्लम हो जाता है. लेकिन एक बार सोर्स पता है तो आप कोई भी रिजल्ट तुरंत सामने भी निकाल सकते हो. Now the question is, this is again an IIT JEE question. B into cos C minus alpha plus C into cos B plus alpha is equal to A cos alpha. ये आपको शो करना है for any real value alpha where ABC is a triangle. कैसे प्रूव करें? How to prove this? सिंपल है, साइड्स दिख रहा है तीनों में. एक तो सिंपल है, साइन रूल लगा के काम कर दो तो लेफ्ट हैंड साइड राइट हैंड साइड आ जाएगा. देखो आ रहा है. I can write this as sin B क्योंकि 2r सबका कैंसिल हो जाएगा. So sin B into cos C minus alpha plus sin C cos B plus alpha is equal to sin A cos alpha. ठीक है, 2r सबका कैंसिल हो गया. sin B cos C cos alpha प्लस साइन बी साइन सी साइन अल्फा, यही होगा ना? कॉस सी माइनस अल्फा. ठीक है, और वो बन जाएगा प्लस साइन सी कॉस बी कॉस अल्फा माइनस साइन सी साइन बी साइन अल्फा इज इक्वल टू साइन ए कॉस अल्फा. राइट? This and this gone. बचा क्या? क्या है कॉमन? cos अल्फा और बेसिकली ये है sin b प्लस c विच इज इक्वल टू राइट साइड में cos अल्फा sin a. ट्रू है क्या? लेफ्ट साइड इज इक्वल टू राइट हैंड साइड. Yes, because b plus c is basically sin a. Clear? एक तो ये मेथड था. एक और मेथड, बेसिकली तूने प्रोजेक्शन फॉर्मूला देखा है, उसी को गौर से देखो. एक्चुअली उसी का वो ये मतलब उसका ये जनरल केस है और इसका स्पेशल केस है प्रोजेक्शन फॉर्मूला. देखो कैसे. Should I rub this? किसी को प्रॉब्लम नहीं है? देखो इस क्वेश्चन को दूसरे मेथड से भी कर सकते थे. देखो एक ट्रायंगल बनाओ. यहां से एक लाइन ले लो. ले लिया? ये एंगल मान लो अल्फा. ओके, नाउ दिस इज योर ए. इसका प्रोजेक्शन इस पे लेना है. तो ये लेंथ क्या हो गया? यही है ना राइट हैंड साइड में. कोई प्रॉब्लम नहीं इसमें? ओके ठीक है. This is C. What would be this length? C cos alpha. C cos alpha plus B. है ना? Clear? Now, this length is actually equal to this length. देखो 90 90 and parallel. Clear? So I can say this length is equal to this length. Now, this is alpha, so this would also be alpha. So this is going to be C minus alpha. So can I say, this is my B. So can I say this length is B cos, so I can say this length is B cos C minus alpha. So I can say B cos C minus alpha plus C cos B plus alpha is equal to A cos alpha. So basically this is your projection formula only. Projection formula is a special case. If I put alpha is 0, it would turn out to be a projection formula. And if you see a random line which is inclined at alpha angle with beta, so you can have the projection in this way also. Clear? So basically projection formula is a special case of this. Slowly. Which step can you please ask him, ask her? उसके बाद maybe explain second step. So उसके बाद they said slowly. काफी slowly ही तो बताए थे. This one right now which is going on. Yeah. See, initially we solved the question through algebraically, and what we did, we just replaced B by 2R sine B and C by 2R sine C and A by 2R sine A. Then we cancelled out all the 2R's. So we were left with only the trigonometric identities on the left and right. So on the left side, we got sine B into cos C minus alpha plus sine C into cos beta B plus alpha, which was equal to sine A cos alpha. Now what I did, I just opened it up. So on the left hand side, I got sine B into cos C into cos alpha plus sine B into sine C into sine alpha plus sine C into cos beta cos alpha minus sine C sine B sine alpha. So the product of all the three sines got cancelled and cos alpha was common, and then we replaced that thing by cos alpha into sine A plus B, and on the right side we had sine B into cos alpha, sine A into cos alpha, and we know sine B plus C is nothing but sine A, so we proved it that left hand side equal to right hand side. But now we have another method also to prove it, because we saw that projection formula was A cos alpha plus B, A cos B plus B cos A is C, and if you observe that projection formula, it was simply an extension of projection formula. So what I did, I just drew a triangle ABC, and then I inclined an angle with a line with angle alpha, and then I took the projection of A on this. So I got that this length is going to be A cos alpha, that is my right hand side. Now I extended A to this perpendicular, so I got C into cos alpha plus beta, another projection, and we saw this portion is actually equal to this portion since it's going to be parallel thing. So I just said that this line is going to be equal to this line. So I can say this is basically C minus alpha. So I can say this portion is B cos C minus alpha. And hence we said that this is B cos C minus alpha and this is C cos alpha plus B. And the right hand side was A cos alpha. Now, going to the 13th property, which is again another major, most important property. We call it cosine rule. And we have already proved it also in coordinate classes, if you remember. So property 13, again one of the most important property of this chapter. It says cos A is equal to b square plus c square minus a square by 2bc. Now the question is how to prove it. Since we know on the left hand side angle, on the right hand side we saw the, so what we should use? Sine rule. So we'll get on the right hand side, I'm just working on the right hand side. So right hand side I can write it, since all are square terms, so it is 4r square, 4r square, 4r square, and then down also we have 4r square. So I'll just get rid of 2r's. So I'll be left with sine square b plus sine square c minus sine square a to sine b sine c, right? A hoga. Now there is no formula for this too. There's no formula for sine square b plus sine square c, but we have something for this. What is that? Sine c plus a into sine c minus a. So I can say sine square b plus sine c plus a into sine c minus a upon 2 sine b sine c. यहाँ तक किसी को कोई प्रॉब्लम है? No? Are we going very fast? No. Now sine c plus a can be written as sine b. So I can write it sine square b plus sine b into sine c minus a upon 2 sine b sine c, right? Can I cut this sine b with this and this square? Huh? So what I am left with, sine b plus sine c minus a upon 2 sine c. No issue till here? Can I write my sine b as sine c plus a? So I write it as sine a plus c plus sine c minus a upon 2 sine c. What is sine this plus this? 2 sine c cos a, because c minus a. So 2 so we got, that is my right hand side, that was my left hand side, hence proved. Clear? So this was my cosine rule. Any issue with this? No? So we have finished 13. We have 27 properties, we have finished 13 properties. Till 13 any issue? Anything which is difficult? Anything which is not understood? No? So 50% is done. And sine and cosine are basically the most important properties. So do not forget it. Now the question is when to use sine rule and when to use cosine rule. We have already made it clear the sine rule to be used whenever we see the sides, and cosine rule will be used whenever we have to deal with the angle. And basically cosine rule is actually Pythagoras theorem is actually a special case of cosine rule. If you observe, what did Pythagoras theorem was? What was Pythagoras theorem was? It said ये ट्राइंगल लो, यही था ना, b स्क्वायर प्लस c स्क्वायर इज a स्क्वायर, राइट है ना? एक्चुअली इसे थीटा बना दो और ये 90 नहीं है, थीटा है. सो व्हाट Pythagoras what the cosine rule says, b square plus c square minus 2bc cos theta, and when it is 90 it goes off, right? So Pythagoras theorem is a special case of cosine rule. So sine rule when sides are to be found, cosine rule when angles are to be found. Clear? Okay, now do the question. Question says there is this cubic equation, okay, whose roots are ABC, where ABC are the sides of a triangle. So you have to say that if ABC, our question is, if ABC are roots of x cube minus 11x square plus 38x minus 40 is equal to 0, find cos A by A plus cos B by B plus cos C by C. Just do it. What is the cos A expression? B square plus C square minus A square by 2BC. देखो फिर cos A क्या हो जाएगा? Cos A by A, cos B by B और cos C by C. Are they sharing all the same denominators? क्या रहा है? Okay, and how to handle A square plus B square plus C square? A square plus B square plus C square is basically sigma A square minus sigma A, 2A, twice of sigma AB, right? तो वो निकल के आ जाएगा ना? Good. See, this is cos A is nothing but B square plus C square minus A square by 2ABC. Cos A by A, right? So I know हर केस में 2ABC ही आने वाला डिनोमिनेटर. बट cos B में एक स्टोरी होगी A स्क्वायर प्लस C स्क्वायर माइनस, एंड यहां कहानी होगी बेसिकली आपको ऊपर में क्या मिला? सिग्मा A स्क्वायर अपॉन 2 पाई A. ये स्टोरी है ना? सिग्मा A स्क्वायर अपॉन 2 पाई A है. एंड नाउ sigma A square can be written as sigma A का square minus twice of समझ में आ रहा है? Now what is sigma A? 11. So 11 square. What is sigma AB? 38. What is pi A? 40. So 121 minus 76 upon 80. So I think that is 45 upon 80. So the answer is, है ना? समझ में आया? कितनों को नहीं समझ में आया? सिग्मा ए से डर गए क्या? See, sigma A square is nothing but A square plus B square plus C, since we know that A, B, C are the terms, right? And sigma is nothing but A plus B plus C. And sigma AB is nothing but AB plus AC plus BC. And pi A is nothing but ABC. Pi means multiplication, right? Clear or not clear? Which question? This one. See, in the question it was given ABC are the roots of this cubic equation, right? And then you had to find this thing. Now you know cos A is nothing but, using the cosine rule, cos A is nothing but B square plus C square minus A square upon 2BC. So eventually cos A by A would give me B square plus C square minus A square upon 2BC, 2ABC. cos b by b would give me a square plus c square minus b square by 2abc, and cos c would give me a square plus b square minus c square upon 2abc. Now since we have all the denominators same as 2abc, so we can add them up together. So in the denominator we will have 2abc, on in the numerator we will have a square plus b square plus c square twice minus a square plus b square c square. So eventually we will be left with a square plus b square plus c square upon 2abc. Now a square plus b square plus c square, I don't know how to get a square plus b square plus c square, but I know how to get a plus b plus c ka whole square, and I know how to get ab plus bc plus ca. So I know a plus b plus c ka whole square minus twice of ab plus bc plus ca, using the concept of sum of the roots, the product of two roots and the product of three roots. I just found my answer. So finally the answer I got is 9 by 16. Clear? पूछेगा स्पीड ठीक थी और फिर से एक्सप्लेन करना है एक बार, जस्ट आस्क रिकन्फर्म. Okay, see, the question was ABC are roots of this cubic equation. Okay, now forget this cubic equation for a time being. You have to find cos A by A plus cos B by B plus cos C by C. Now I don't know what is cos A by A, but surely I know what is cos A. Using the cosine rule or the property 13, I know cos A is B square plus C square minus A square by 2BC. Right, and cos A by A eventually would be 2ABC, and similarly cos B is going to be, cos B by B is going to be A square plus C square minus B square by 2ABC, and then cos C by C is basically going to be A square plus B square minus C square upon 2ABC. Now if you add these three, you on the left hand side you have this thing. So you can make it that if this plus this plus this is actually this plus this plus this. So I can make sure that it is nothing but b square plus c square plus a square ka twice minus a square plus b square plus c square upon 2abc. Okay. Now this is actually a square plus b square plus c square upon 2abc. Now a square plus b square plus c square, long time ago when you were in class 9th, there was this formula a plus b plus c ka whole square minus twice of ab plus bc plus ca upon 2abc. Now what is a plus b plus c? I know sum of roots is going to be 11, so I just wrote 11 square. I know the pair products is going to be plus 38, so I just made it through 2 into 38, that is 76. And I know the product is going to be 40, so I just wrote 80. So 121 minus 76 is 45 by 80, and that is 9 by 16 QED. Can you come down? Next. I hope clear now. Miss Kusum. Now you have the property 14. It's also one of the most important property. Now it says cos A by 2 is equal to under root of S into S minus A by BC. Now, how to go for it? Any idea? Cos theta 2 theta की identity से, so I can say cos A by 2 is nothing but 1 plus राइट, यही होगा. नाउ व्हाट इज cos A, मिस्टर कोसाइन? Right? So I can say this as 2bc plus b square plus c square minus a square upon 4bc. Which I can write, this is a perfect square. So I can write b plus c ka. Now this is the difference of two squares. So b plus c plus a into b plus c minus a. अपॉन 4bc है, तो इसमें मैंने 2 डाल दिया, इसमें डाल दिया 2bc. Right? So what is it? S into s minus a. So cos a by 2 is basically under root s into s minus a into upon bc, right? Clear? कोई problem इसमें? Easy to prove. Now similarly, the next property, the property 15. Should I rub this? वहां से कोई problem नहीं है? Sine a by 2 is equal to s minus b into s minus c by bc. Now how to prove this? Again 1 minus cos वाला concept करते हैं. Okay, so sine a by 2 can be written as right, and cos a can be easily written as right, which eventually can be written as a square minus b square plus c square minus 2bc upon 4bc. देख सकते हैं ऐसे? ये तो सबको समझ में आ रहा है ना? देखो ये इधर आया था, ये आया था 2bc माइनस बी स्क्वायर माइनस सी स्क्वायर प्लस ए स्क्वायर. तो ए स्क्वायर को मैंने प्लस को इधर रख दिया, माइनस करके बी स्क्वायर प्लस सी स्क्वायर माइनस 2bc कर दिया. ओके, सो आई गॉट इट एज ए स्क्वायर माइनस बी माइनस सी का होल स्क्वायर बाई 2. राइट? नहीं बाय 4bc. Now this is again the difference of two squares. By 2. Right? This is s minus c and this is s minus b. राइट, हमने पहले ही बता दिया था ना, a प्लस बी प्लस सी, a प्लस बी माइनस सी, a प्लस बी, a प्लस सी माइनस बी, a b प्लस सी माइनस ए. एक्सप्रेशन का मतलब क्या होता है? राइट, सो साइन a by 2 इज ऑल्सो क्लियर. राइट, अब आ गया है टाइम प्रूफ करने का कि डेल्टा इज इक्वल टू अंडर रूट एस इंटू एस माइनस ए इंटू एस माइनस बी इंटू एस माइनस सी. कैसे करेंगे? What is area of a triangle? Half BC sin A. And what is sin A? 2 sin A by 2 cos A by 2. करो, प्रूफ करो, जल्दी करो. हो गया सबसे? Anyone stuck somewhere? No? सबसे हो रहा है? तुम स्टक हो गई कहाँ पे? अच्छा See, property 15 was simply the Herons formula. Delta is equal to under root S into S minus A into S minus B into S minus C. Now, since we know delta is basically half BC sine A, right? And half, which I can easily write it as 2 into sine A by 2 cos A by 2. So gone, which I can write BC into what was sine A by 2? Under root S into S minus A by BC. Under root S minus B into S minus C by BC. So basically I'm left with under root S into S minus A into S minus B into S minus C. खत्म. ठीक है? This was property 16, right? So sine A by 2 done, cos A by 2 done, area is done. Now let's find tan A by 2. That is my property 17. Let's see what is tan A by 2. Sine A by 2 by, so property 17 talks about tan A by 2. Let's see what is tan A by 2. Is basically under root S minus B into S minus C upon S into S minus A. ये बात कितनों को समझ में नहीं आया? ये बात कितनों को समझ में नहीं आया कि tan A by 2 यही होगा? मैं भी प्रूफ कर रहा हूँ. एक्चुअली तुम्हें प्रूफ करना है. प्रॉपर्टी 17 इज R is by S minus A is tan A by 2. ये तुम्हारा प्रॉपर्टी है. इसे प्रूफ करना है. ओके, दिस इज द प्रूफ यू नीड. ओके, ये तो पता चल गया कि यही होगा क्योंकि sin A by 2 was under root S minus B into S minus C upon 2BC और ये था S into S minus A upon 2BC. तो 2BC कैंसिल आउट. अंडर रूट था, अंडर रूट ऊपर दोनों आ गया. सो आई कैन से अंडर रूट S minus B into S minus C into S minus A upon S square into S minus A का स्क्वायर. सो ऊपर आ गया ट्राइंगल और नीचे आ गया S into S minus A. एरिया आ गया ना ऊपर. क्या आ गया? एंड व्हाट इज डेल्टा बाय एस? क्लियर? नॉट क्लियर? प्रॉपर्टी 1 डेल्टा बाय एस इज आर. सो आई कैन से tan A by 2 इज बेसिकली we can also say it is equal to R by RA by S. This is property 18. क्यों? प्रॉपर्टी 2 क्या था? RA is equal to डेल्टा अपॉन S माइनस A. तो ये जो चीज है यहां से दो आंसर्स आ रहे हैं. एक ये कि डेल्टा बाई एस ले लो तो R बाई एस माइनस ए और डेल्टा बाई एस माइनस ए ले लो तो RA बाई, both are same story, right? So this is property 18. So tan A by 2 is R by S minus A and tan A by 2 is also equal to RA by S. Clear? So no issue with 17 and 18? Okay, can you come down? Okay, which one? Property 7. Okay, 17. See, in property 17, they say tan A by 2 is equal to R by S minus A. ये हमें प्रूफ करना है. Since I know tan A by 2 is basically sine A by 2 by cos A by 2, and I know sine A by 2 is nothing but under root S into S minus, S minus B into S minus C by 2BC. And cos A by 2 was S into S minus A, 2BC. Now since I know दोनों में रूट है तो दोनों को अंदर ले जाओ, s minus b s minus c by 2bc into s minus a 2bc, gone. So you are left with s minus b into s minus c. Now just multiply and divide by s into s minus a, so you will get s square s minus a square. Now ऊपर आ गया आपके डेल्टा का डेल्टा आ गया, नीचे आ गया आपको s into s minus a. Now since you know delta by s into 1 upon s minus a, which is equal to r by s minus a, right? Clear? And property 18 says tan a by 2 is actually equal to ra by s, which I can say I'll follow the same routine and यहाँ पे आके मैं change कर दूंगा. यहाँ पे I can say that delta by s minus a into 1 by s, this is nothing but ra, that is x radius. Clear? So 17 and 18 is clear. Now the 19th property is, it's also a property, and they have asked in IIT-JEE also this question. So basically after IIT-JEE question, they have asked, when they asked this question, they have included it as a property after that only. So it turned out to be, this property turned out to, but this question actually became a property. Now what is the question? You have to show that was property 19, this is property 19. You have to show that r is equal to 4r sine a by 2 sine b by 2 sine c by 2. Now how to go for it? Obviously right hand side से काम करेंगे. So I can say my right hand side would be 4r. What is sine a by 2? है ना, इसी को एक्सटेंड कर दो, क्या हो जाएगा ये s minus a into s minus c by 2ac, और ये हो जाएगा s minus a s minus b by 2ab. यही होगा ना, जिसमें से क्या किया जाए, a स्क्वायर b स्क्वायर c स्क्वायर आ गया तो बाहर निकाल दो 4r by abc. ठीक है, ये आ गया, और अंदर रह गया 1/2 भी बाहर निकाल दो, तो यू आर लेफ्ट विथ हाफ इंटू s माइनस a का, कुछ गड़बड़ कर दिया क्या? 2 नहीं है ना, bc है ना सिर्फ. ओके Okay, so you are left with under root s minus b का square into s minus a का square into s minus c का square. So I can get rid of that easily of the root. I can say 4r by abc is equal to s minus b into s minus a into s minus c upon, if I put s. Clear? क्या हो गया ये डेल्टा स्क्वायर हो गया 4r by abc into delta square by s. What is 4r by abc? abc by 4r क्या था? Delta था. So I can say delta square by delta s. Finally delta by, which is equal to, this was your IIT-JEE question, and this turned out to be your property as well. So r in radius is basically 4r into sine a by 2 sine b by 2 sine c by 2. Clear? वहां से कोई कॉलम नहीं. Now property 20 is RA is equal to 4R sine A by 2 cos A B by 2 cos C by 2. क्या हुआ? यहाँ पे अब x रेडियस आ गया है, और उस समय था साइन b बाई टू, साइन b बाई टू, साइन c बाई टू, अब क्या है साइन a बाई टू रह गया, लेकिन ये दोनों बंदे कॉस हो गए, तो ये भी प्रूफ हो जाएगा आराम से। राइट हैंड साइड में जाएंगे, सो आई कैन से 4r इंटू s माइनस b to s minus c by bc, s into s minus b by bc, sorry ac, s into s minus c by ab, ये होगा ना। तो आई कैन गेट rid of 4r by abc is equal to s minus b का स्क्वायर, मतलब s minus b बाहर आ गया, s स्क्वायर s भी बाहर आ गया, और s minus c भी बाहर आ गया। ठीक है, अब क्या करें, s minus a से मल्टीप्लाई डिवाइड, so I got delta square by delta into s minus a, so eventually I got समझ में आया। So till 20 properties, anything is troubling you? नहीं, सब इजी थे प्रूफ करना, भूल भी गया तो निकालना जानते हो, पैटर्न समझ में आ रहा है। ये तुम्हें किसी भी बुक में अरेंज्ड ऑर्डर में नहीं मिलेगा, I've arranged it so that everything starts making sense to you. Clear? तो ये सारे एक के बाद एक के बाद एक ऑर्डर में मैंने डाला है, और नॉर्मली तुम्हें हमेशा ये दो फॉर्मूला उधर लिखा हुआ मिलता है, दो फॉर्मूला उधर लिखा हुआ मिलता है, दो फॉर्मूला इधर लिखा हुआ मिलता है, तो उसमें क्या होता है कि तुम हर बार प्रूव करने में तुम्हारा दिमाग खराब होता रहता है। Can you go to the next page? हो सकता है तुमने ट्रिग्नोमेट्री में किया हो, 3 एंगल्स के सम वाला किए, प्रूफ किया है, चलो प्रूफ करो। फॉर एनी एंगल एक्स वाई जेड, for any angle xyz, prove that, show that, this is your 21st property, for any angle, not of triangle, any angles, show that first x plus y plus z is actually equal to sigma sin x cos y cos z minus sigma sin x pi sin x। सिग्मा और पाई का मतलब सबको समझ में आता है ना, cos x plus y plus z is actually equal to pi cos x minus cos x sin y sin z, and third tan x plus y plus z is equal to sigma tan x minus pi tan x upon 1 minus sigma tan x tan y। इसे रट लो, प्रूफ करके रट लो, करो प्रूफ करो, करो जल्दी प्रूफ करो तीनों को। कैसे करेंगे प्रूफ, x प्लस वाई प्लस जेड है ना, तो पहले x प्लस वाई को a मान लो, एंड देन ओपन इट अप sin a प्लस जेड, तो दैट वुड बी इक्वल टू sin a cos z प्लस sin z cos a। अब sin a को लिख दो sin x प्लस वाई, ओपन अप करो, तो यू विल गेट द पैटर्न। सी लिखो, देखो साइन एक्स प्लस वाई प्लस जेड को मैं खोल सकता हूँ साइन एक्स प्लस वाई कॉस जेड प्लस कॉस एक्स प्लस वाई sin z, and then I can open it up cos z into sin x cos y plus sin y cos x plus sin z into cos x cos y minus sin x sin y, which I can write it as sigma sin x cos y cos z, because I can see three terms, minus phi sin x. यही था ना, एक लाइन है प्रूफ. सी दिस इज, देखो ये तीन टर्म्स पे देखो, तीनों प्लस वाले टर्म्स को देखो, सब में दो बार कॉस है और एक बार साइन है और इंटरचेंज कर रहा है, राइट. तो आई कैन राइट इट साइन एक्स कॉस वाई कॉस जेड, तीन टर्म्स है सिग्मा करके, माइनस आई सी साइन एक्स साइन वाई साइन जेड, ऑल क्लियर. उसी तरीके से सेकंड पार्ट करो, cos x plus y into cos z minus sin x plus y into sin z. So I can write it as cos x cos y minus sin x sin y into cos z minus sin x cos y plus sin y cos x sin z. Now observe, this fellow is alone with all the cos, right? So I can write it pi cos. And minus के साथ क्या है, दो sin है और एक cos है. So I can write it sin x cos y cos z. दो sin है क्या? Okay. So cos x sin y sin z. Clear? Okay. Coming to the tan one, tan says tan of x plus y plus tan z upon 1 minus tan z tan x plus y, right? And then I can write it as tan x plus tan y upon 1 minus tan x tan y plus tan z upon 1 minus tan z into tan x plus tan y upon 1 minus tan x tan y. दोनों इसको इधर ले जाके दोनों का डेरिवेटिव सेम होगा तो हटा सकते हैं. सो आई कैन से tan x plus tan y plus tan z minus pi tan x, ठीक है, upon 1 minus sigma tan x tan y. So I can say sigma tan x minus pi tan x upon 1 minus sigma tan x tan y. Clear or not clear? Which one? 19th and 20th. Can you go to the back? So this is done, all the sine x plus y plus z for all sine, cos and tan. Now, see, I'm repeating question number 19 and 20. In question 19, that was my property 19, which I had to prove that R is basically 4R into sine A by 2, sine B by 2, sine C by 2. Since I will be working on the right hand side, so I know 4R, but I know what is sine A by 2. It was S minus B into S minus C by BC. And similarly, sine B by 2, since it is a cyclic in property, so it would be equal to sine S minus A into S minus C by AC, and it would be S minus A into S minus B by AB. Now, since all the three are in the roots, so I can bring them in one umbrella, and I can say S minus का whole square, S minus B का whole square, S minus C का whole square upon ABC का whole square. So I can get rid of my square root as 4R by ABC into S minus A into S minus B into S minus C. What I see, the missing term is S. So what I do is multiply, divide by S. So I know this is also the property we have already proved, that 4R by ABC is nothing but 1 upon area of the triangle, and this is nothing but delta square, and this is nothing but S. So I can say delta by S is nothing but R. Right? Now, any issue in 19th? I hope everything is done. Now going to 20th, the property 20th says that X center of RA or R2 or R3 is equal to sine, right? Same way I'm going to work on my right hand side. I know this is 4R. Sine A by 2B can be written as S minus B into S minus C by BC, and cos B can be written as S into S minus B by AC into S into S minus C by AB. So now I can get rid of, see ABC, I can get my thing as ABC, and I know S square will be S, S minus B and S minus C. Now what is missing here is S minus A, so I'll just put S minus A, and then I will say this is 1 by delta, this is delta, and this delta square, and this is S minus A. So I can say delta by S minus A, and my property 2 says this is RA. See, when I talk about summation or multiplication, that's sigma. See, when I say sigma sine x or cos x or tan x, it means since it is a cyclic, it's triangles के तीनों angles cyclic हैं, so sigma sine x can be written as sine x, sine y plus sine z. That is it, nothing more than this. So instead of writing these three terms, I just wrote it sigma sine x. Now if I have to write, when I say pi sine x, it means sine x into sine y into sine z. If I put cos, cos. If I put tan, tan. Sigma sine x cos y cos z. It means, again, the format of the term is going to be sine cos only, and x, y, z will be interchanging with each other. Sine x cos y cos z plus sine y cos z cos x plus sine z cos y cos x. That's it. Sigma sine x sine y means sigma sine x sine y plus sine x sine z plus sine y sine z. इस तरीके से लिखते हैं हम लोग, just a short form. So sigma means sum, pi means product. That's it. Now tell me, the question says RA, RB and RC are in AP. Show that tan A by 2, tan B by 2 and tan C by 2 are also in AP. I think एक ही line approve हो जाएगा. क्यों? What is tan A by 2? R into R by S minus A, right? Or RA by S. So RA is basically delta into tan A. So I know delta into tan A by 2 delta into tan A by 2, delta into tan B by 2, delta into tan C by 2 are in AP. So obviously tan A by 2, tan B by 2, tan C by 2 will also be in AP. Right. Now, in the 20th properties was for any three angles. Doesn't matter whether they belong to a triangle or not, right? X, Y, Z was any three angles. Now coming to triangle ABC. Now coming to triangle ABC, show that first, this is your 22nd property. Show that first one, triangle ABC की बात हो रही है, not for any random. You have to first show that sigma sine 2a is equal to 4 pi sine a. पहले ये करो फिर सेकंड थर्ड करेंगे. देखो सिग्मा साइन 2a मतलब क्या हुआ, साइन 2a प्लस कॉस 2a प्लस सॉरी साइन 2a प्लस साइन 2b प्लस साइन 2c which is equal to 4 into pi sine a, which means 4 into sine a into sine b into sine c. This is just a notation of writing those long term into a very short term. Now I have to prove this, so I'll start my story from left hand side. So 2a is not an angle of a triangle. A is an angle of a triangle. So I can say sine 2a, left hand side पे काम शुरू करो. Sine 2a, sine 2b, sine 2c. Now what is sine c plus sine d? 2 into sine c plus d by 2 into cos. So I can say 2 into sine a plus b into cos. Any doubt? So these two terms can be written this way. And sine 2c can be written as right. Now I see 2 sine c here and I see 2 sine ab. Are they equal? So can I take it out? So I'll say 2 sine c cos a minus b plus cos c, which can be written as cos pi minus a plus b, which can be written as minus of. ये बात कितनों को समझ में नहीं आया? अच्छा वहां नहीं समझ में आएगा, फिर से लिखते हैं. ओके 2 sin c plus cos c. Cos c can be written as cos pi minus a plus b, right? And then I can write it as 2 sin c into cos a minus b. Cos pi minus theta is minus cos theta. So minus cos a plus b, right? यहां तक कोई प्रॉब्लम है किसी को? No. Now what is cos a minus b minus cos a plus b? Plus 2. Plus 2 sine ab. So it would be 2 sin c into 2 sin a, which is actually equal to 4 which equal to 4. Clear? कहां cos आ गया? क्या हो गया? क्या हो गया? cos a minus b is cos a cos b plus sin a sin b minus cos a cos b plus sin a sin b. तो खत्म हो गया ना, twice of sin a sin b बचा ना. Clear? Now second part, sigma cos 2a देखो इसे प्रूफ बार बार नहीं करोगे, इसे रट लेना, ठीक है. सिग्मा cos 2a is equal to -1 minus 4 pi cos a. ये प्रूफ करना है. अगेन सेम ड्रिल, cos 2a. ओहो टाइम गोइंग ऑन, टाइम खत्म. So cos c plus cos d is twice of cos c plus d in by 2 into cos c minus d by 2. So basically twice of cos a plus b into cos a minus b plus 2 cos square c minus 1. This is basically cos a plus b can be written as minus 2 cos c, है ना? So minus 2 cos c cos a minus b plus 2 cos square C minus 1. So I'm left with cos C minus cos A minus B minus 1. Now cos C again can be written as minus of cos A plus B. तो बाहर minus ले आओ. Cos A plus B plus cos A minus B minus 1, which will eventually give me 2 cos A cos B. So eventually you will get minus 4 pi cos A minus 1. Clear? And similarly tan 2A के लिए इतना लंबा प्रूफ करने की जरूरत नहीं है. बताओ क्यों? Since you know tan x plus y plus z was sigma tan x minus pi tan upon 1 minus sigma tan x tan y. But it is 2a plus 2b plus 2c. 2a plus 2b plus 2c. That makes 360 degree. What is tan 360 degree? 0, which means numerator has to be 0. So I can say sigma tan 2a is equal to pi tan a. Tan 2a. Clear? Okay, till here we are finishing up this till here 22. So last 6 properties are left. Then we'll discuss pedal triangle and then we'll also discuss more of the properties के questions कैसे होते हैं, right? So till here no issues. इस properties को एक साथ arrange कर लें और इसको regular derive करते रहा करें so that it should stay here, right? Okay.
Today we are going to learn hydrocarbons. Let us start first by defining hydrocarbons. Next slide, please. What are hydrocarbons? Hydrocarbons are those organic compounds which contain only carbon and hydrogen. Now, if you look at so many things about around you, you find that hydrocarbons have numerous uses in our daily life. For example, the gas burners which you use in your kitchens, then the plastics that you use, the solvents in the paints, the laying of the roads, the fuel which runs the automobiles, they are all coming from hydrocarbons. Let us look at the classification of hydrocarbons, how they are classified. So ideally, hydrocarbons are classified into two categories, the aliphatic and the aromatic compound. The aliphatic compounds, they are further classified into alkanes, alkenes, and the alkynes. Alkanes are those hydrocarbons which contain only carbon-carbon single bond. Okay, they are called the saturated hydrocarbons. Now, I've given you two examples here. If you see on the right side, if you see that example, that compound is ethane, and on the left, that compound is cyclopentane. That means these alkanes can either be open chain, like the case of ethane, or they can be cyclic, like in the case of cyclopentane, right? The alkenes are those hydrocarbons which contain at least one carbon-carbon double bond. They are called the unsaturated hydrocarbons. Now, like the alkanes, they can also be open chain or they can be cyclic. Now, one example of an open chain alkene I have given you here, that is of ethylene. Cyclic alkenes can be compounds like this is cyclohexene, and this compound is cyclopentene. All right. Alkynes are those hydrocarbons which will contain at least one carbon-carbon triple bond. Again, they are unsaturated hydrocarbons. The simplest member of the family is acetylene, that I've given the example here. Besides the open chain compounds, the alkynes could also be cyclic, like the alkanes and the alkenes. One example I'm giving you. This compound will be called cyclohexane, right? The next category of hydrocarbons is the aromatic hydrocarbons. Aromatic hydrocarbons are those compounds which contain at least one benzene ring. Okay, they are called benzenoid aromatics. Those aromatic compounds which contain one benzene ring. Now, there are three examples that I have given you here. The one in the center is the benzene. On the right side is a compound that is called toluene, and on the left side is a compound that is orthoxylene. It is xylene. Dimethyl benzenes are called xylene. The two methyl groups occupying ortho position, so it is orthoxylene, right? Next. Now, what are alkanes? Alkanes, we said they are saturated hydrocarbons which have a general formula of CnH2n plus 2 if they are open chain, right? And if they are cyclic, then they will have a general formula of CnH2n, right? Now, these compounds, they are called paraffins. The word paraffin comes from two words, param, which means less, affinus means reactive. Now, these compounds, they are very less reactive. In fact, they do not show any reactivity under normal conditions of temperature and pressure. Okay. However, we will see today that at higher temperature and pressure conditions, these alkanes, they do show some reactions. All right. Next slide. If you look at the structure of alkane, the simplest member of the family is methane. Now the carbon at the center is sp3 hybridized with 4 sp3 hybridized orbitals which are occupying 4 corners of the tetrahedron. Each of these sp3 hybridized orbital overlap with 1s orbital of hydrogen to form 4 sigma bonds, right? And if you go from methane to ethane, will have a structure like this. What is the bond length of the carbon-carbon bond? The bond length of the carbon-carbon bond is 1.54 angstroms. The bond length of the CH bond is 1.10 angstrom. And the bond angle, the HCH bond angle is how much? 109 degree, 28 minutes, right? So that is what the structure of alkanes is like. Let us go now on to their physical properties. The first is their nature. Alkanes being non-polar compounds, the only kind of forces of attraction which will exist in alkanes are the weak van der Waals forces of attraction, right? Now these van der Waals forces of attraction will depend upon the size and the shape of the molecule, right? So as the size increases, the van der Waals forces of attraction will increase. So what you find is that the first 4 members of the family, they are gases, small chain, very weak intermolecular forces of attraction. Then from 5 to 17, they are liquids, and the higher members are solids. Okay. Next is their boiling points. Now again, boiling point of an organic compound depends upon its intermolecular forces of attraction. As the chain length increases, the van der Waals forces of attraction in the molecule will increase. So the boiling points are expected to increase, right? If you look at the 3 compounds that I have listed here, heptane, octane and nonane, you find that as the carbon chain increases, the boiling point progressively goes on increasing because the size is increasing. As the size increases, the intermolecular forces of attraction are increasing, and as the intermolecular forces of attraction increase, the boiling point of the organic compound goes on increasing, right? Now what happens when you have branching taking place in the chain? I've given you 3 compounds here. One is octane, the second one is 2-methyl heptane, and the third one is 2,2,3,3 tetramethyl butane. So you have seen that the branching goes on increasing as you go down from top to bottom. So the boiling points are progressively decreasing. This is because as the branching increases, the molecule becomes more and more compact. Because it is becoming more and more compact, it is approaching the spherical shape, the intermolecular forces of attraction, they are decreasing. That is why, because of branching, the boiling points will decrease. Let us look at this slide and tell you what are the type of forces of attraction which exist in non-polar molecules like alkanes. Now, you know that the electrons are going around the nucleus, right? When the electrons go around the nucleus, there is a slight polarity being introduced in the molecule or the atom, right? Because of that polarity, what happens is, next slide. Now you can see here this atom has acquired a dipole. There is a charge separation. Now, because of this charge separation, it will introduce similar type of charge separation in the adjoining atom. Because of which this atom will also get polarized. Now you see that? This atom has also become polarized. This is what you call induced dipole type of interaction. Because of which these two atoms now have become a temporary dipoles. So these atoms, they start attracting each other, and because of these attractions, you have variations in the boiling point of the molecule. So higher the number of such interactions, higher will be the boiling point of an organic compound. Just showing you how the electron is going round, and now the polarities have changed. The opposite signs close together and the atoms attracting. Next slide. Now, this is an illustration which shows you if you have a straight chain molecule, there are so many points of interaction, because of which the van der Waals forces of attraction are very high. All right. But if you have a branched molecule like this, there are very few points of interaction between the two chains, because of which the van der Waals forces of attraction decrease, and hence the boiling point decreases. All right. Next, let us come to the melting point. Again, melting point of an organic compound we are talking of alkanes here, will depend upon the van der Waals forces of attraction. So like the boiling point, you expect the melting points also to increase as the chain length goes on increasing. But what one finds is that the variation in melting point is not as regular as the variation in boiling point that you observe for the case of alkanes. The reason being, you find that the alkanes having even number of carbons have a higher melting point than those having odd number of carbons. And that is what you call the alternation effect. Okay? If you see, I've given you the melting point of hexane, and I've given you the melting point of pentane. If you look at the melting point of heptane also, which has one carbon more than hexane, the melting point will be lower than that of hexane. That is what you call the alternation effect. How do you explain the fact that even though the number of carbons have increased, the melting point is still lower? Now, one thing that we have to understand here is that melting points of organic compounds, besides depending upon the size and the shape, will also depend upon how well an organic compound fits into the crystal lattice. The more symmetrical the structure of the molecule, more easily it fits into the crystal lattice, stronger are the intermolecular forces of attraction, higher will be the melting point, right? Now, if you look at the even chain compound, the terminal carbons are on the opposite sides. How many carbons are these? 6, right? The terminal carbons are on the opposite side, whereas in an odd chain compound, you find that the terminal carbons are on the same side. Now, because in the case of an even chain molecule, the terminal carbons are on the opposite side, they are found to fit better in the crystal lattice because of the close packing of the even chain alkanes. They have stronger intermolecular forces of attraction and they have higher melting point. Okay, so the thing is that they are fitting better because they are more symmetrical, they fit better in the crystal lattice, so their melting points are higher. Okay, next slide. Coming on to their solubilities, there is a golden rule that you have to always remember when you talk of solubility of organic compound, and that golden rule is like dissolves like. Means if you have a non-polar organic compound, it will dissolve in non-polar solvent. If you have a polar organic compound, it will dissolve in polar organic solvent. Now, alkanes, they are non-polar, so they will not dissolve in a polar solvent like water, whereas they will be freely soluble in non-polar solvents like benzene, chloroform, carbon tetrachloride, etc. Right? Next, let us look at their methods of preparation. Now, though the major source of hydrocarbons in nature are the petroleum and the natural gas, all the hydrocarbons cannot be obtained from the natural sources. So some of them have to be prepared in the laboratory. There are 4 different methods of preparation of alkanes that we are going to discuss. The first one starts from the alkyl halides. Alkyl halides, you will see, can be converted into alkanes by 4 different methods. Okay? Aldehydes and ketones can be converted into alkanes by reductions involving Clemenson's reduction or the Wolff-Kishner reduction. Then carboxylic acids can be converted into alkane by 2 methods. One is the decarboxylation reaction and the second one is the coal-base electrolysis. Right? And the last method is the hydrocarbons, the alkenes and the alkynes. You know, they can be subjected to hydrogenation reaction to give you alkanes. So we will start with the hydrogenation reaction first. The first of the methods of preparation is the hydrogenation reaction from alkenes or from alkynes. Now let us write a simple molecule. Unsaturated hydrocarbons like alkenes or alkynes can be subjected to hydrogenation in presence of catalysts like Rene nickel, palladium or platinum. Now these are efficient catalysts, so the reaction takes place normally at room temperature. If you replace Rene nickel by ordinary nickel, then the reaction has to be carried out at higher temperatures of about 250 to 300 degrees centigrade. And that reaction is called the Cbse-Udaan reaction. Okay, it is called the Cbse-Udaan reaction. So alkenes will add 1 molecule of hydrogen to form alkanes, whereas alkynes will add on 2 molecules of hydrogen, right? If I have ethylene here, it will add on, say, I'm doing the reduction with palladium. It will add 1 molecule of hydrogen to form ethane, whereas if I start with acetylene, it will add 1 molecule of hydrogen and you will get first ethylene, and then this ethylene will further undergo hydrogenation with 1 more molecule of hydrogen and you will get ethane. Okay? Now the important thing you have to remember here is that as far as the stereochemistry is concerned, the 2 hydrogens, they add on the same side. The addition of the hydrogen is Sine. Sine means both the hydrogens will add from the same side. All right? Next slide. I've taken one example here. I will just explain this, how this is happening and what I mean by Sine addition. Before I discuss this, there is a small mnemonic which I want you to remember. This will help you whenever you're talking of addition reactions of alkene. And what is that mnemonic? If you have a cis compound, okay, and it undergoes Sine addition, it will always give you the mesoisomer, CSM. right? Likewise, if you have a trans compound and it undergoes Sine addition, it will give you a racemic mixture. So if you can remember this, you can very quickly write the addition products on a carbon-carbon double bond and give their stereochemistry. Okay? So with this little hint in hand, let us take up this example and understand how you are getting one mesoisomer in case of the cis product and how you get a pair of enantiomers in the case of the trans product. What alkene is this? What will be the IUPAC name of this alkene? This alkene will be 4,5-dimethyl 4-hexene, right? It will be 4,5-dimethyl 4-hexene, hexene octane, 6 and 2, 8, 4-octane, right? Now, if there is hydrogenation reaction taking place here, I said it is a Sine addition, means the adding hydrogens will come from the same side. Okay? So what will be the product that you will get? That is the product you will get. Now, if you write the Fisher projection for this, how will you write the Fisher projection for this? Rotate kar do isko. Yeah, rotate it. So what will happen? Whatever facing you will go back. Na? That's what it will be. So you can see there is a plane of symmetry here. Right? So Sine addition on a cis alkene has given you a mesoform. Right? Clear or not? Let us take the other example. You will understand that better. Now, the hydrogen could add either from this side or it could add from this side. In the first case, if the hydrogen is adding from the top or the bottom, you will get the same product. Please try that and see. Okay. Now here, when the hydrogen is adding from the top, what will happen? This is what you will get. Right? And if you write the Fisher projection formula of this, what will be it? The Fisher projection formula. This will be one of the product when the hydrogen is coming from the top. Okay? But what when the hydrogen comes from the bottom? In that case, what will happen? That's the product you will get. Huh? And what will be the Fisher projection for this if you write this? So how are the two molecules related to one another? This and this. How are these two related to one another? They are mirror images. Huh? So you got a pair of enantiomers being formed. Right? That is what I said. When you have a cis alkene and it is undergoing syn addition, you get a mesoform, and you have a trans alkene, it is undergoing syn addition, you will get a racemic mixture being formed. So we got a pair of enantiomers, right? Okay. Next. See, this is how this carbon is. Okay? If this is C3H7, which is facing me, okay? When I rotate it, see? This is how it was. This is C3H7, this is CS3. When I rotate the molecule, CS3 comes here, C3H7, and this is CS3. Is that okay? Very easy. Just hold it like this. This is CS3 and this is C3H7. When I rotate it, that's what I did, no? C3H7 will come where? On my left. Where does it go? It comes on my left and CS3 comes on my right. That's how it is. Okay? Enantiomers are mirror. They are mirror images. Like for example, if you see this molecule and this molecule, if you put a mirror here, huh? Then so how are they related to one another? They are related to one another as mirror images. Okay? Huh? Yeah, the next slide, please. The next method of preparation is from the alkyl halides. Now, I told you that alkyl halides can be converted into alkanes by 4 different methods. The first of those methods is the reduction. Okay, this reduction can be done with hydrogen in zinc, HCl, or it can be done with lithium aluminium hydride, or it can be done with sodium borohydride. The only thing you have to remember here is when you have an alkyl halide and you are reducing it, what happens is the Cl or the halogen will be replaced by hydrogen. That's all it is, right? Now, lithium aluminium hydride is a very strong reducing agent. Number one. Number two, tertiary alkyl halides, they are very, very reactive. So, you should avoid using lithium aluminium hydride when you are taking tertiary alkyl halides, because the tertiary alkyl halides, instead of the reduction reaction, will undergo elimination reaction to give you alkenes. Okay? So, in case of tertiary alkyl halide, you should reduce, you should not use lithium aluminium hydride. Okay? What can you use then? You see here, sodium borohydride reacts with the secondary and the tertiary alkyl halides only. So, if you have to reduce a secondary or a tertiary alkyl halide, you can preferably use sodium borohydride as the reducing agent. Is that okay? So, just remember, you have a CX bond. When you are doing the reduction, it is changed into a CH bond. That's all reduction is about for alkyl halides, right? Okay. Next, let us come to the Wurtz reaction. Wirth reaction is the reaction of alkyl halides when two molecules of alkyl halides, they combine in presence of sodium and dry ether as the solvent. So what is the reaction actually? For example, if I take ethyl bromide, okay, two molecules react in presence of sodium and dry ether. How do you write the product? Just forget these and combine the carbons which were linked by hydrogen to each other and you get the product. Okay, that is the way to write the product. Now this will be very useful when we discuss questions, because what happens in the questions is you will not get to do word synthesis. You will get, they will give you an alkane. They will ask you to predict what alkyl halides were used to do the synthesis. So what you have to do is you have to locate the center of the molecule. Locate the center of the molecule and divide it into two, and those carbons have to be joined to halogens. That is how you can predict the starting alkyl halide which was used to prepare the alkane. You get what I'm saying? Okay. Now, the disadvantage of the Wirth reaction is that it cannot be used, or it is not a very good method, I would say, to prepare hydrocarbons which are having odd number of carbons. The reason being, yes. For example, if I am reacting ethyl bromide with methyl bromide in sodium and dry ether, what will be the products I will get? Will I get only propane? See, a 2-carbon chain and 1-carbon unit combining, you get, of course, you will get this. But besides this, you will have ethyl bromide reacting with itself, so you will get a normal butane also being formed as a product. And also CH3Br will combine with itself to form. Now, why do we say this method is not very good when you're preparing alkanes having odd number of carbons? Is because all these hydrocarbons, all these alkanes, they have very close boiling points. Because they have very close boiling points, they're very difficult to separate. Okay? That is why we should avoid doing a Wirth reaction or Wirth synthesis when you want to prepare alkanes having odd number of carbons. Of course, you can't prepare methane by this reaction, right? Because there's only 1 carbon in methane, right? क्या एक्सप्लेन करूं बेटा, क्या समझ में नहीं आया बता दे। देखो मैंने आपको क्या बताया, when you have an alkyl halide, the carbons which are joined by halogens, they get linked to one another. You understand this? This carbon will get linked to this carbon, okay? But besides this, you know, how will you stop ethyl bromide from reacting with itself? है कि नहीं? So ethyl bromide will react with itself to form normal butane. Likewise, methyl bromide will also react with itself and you will get ethane formed as the product. Okay? Next reaction. The next preparation from alkyl halides is what we call the Curie-House synthesis. Now, Curie-House synthesis also is a method to convert alkyl halides two alkanes, the advantage over Wurtz's reaction is that can be used to prepare alkanes having both odd or even number of carbons, right? So how does the reaction actually take place? The only thing you have to remember when you are doing a Curie-House synthesis is that you should start with a primary alkyl halide. Okay? Take alkyl halide, react it with lithium, you will get alkyl lithium being formed. This alkyl lithium you react with cuprous halide, and the product will be two of these molecules combining. This compound is called Gilman's reagent or commonly called lithium organocuprates. Okay? It is called Gilman's reagent or lithium organocuprates. Now that is your starting material to prepare alkane. You will start with this organo lithium cuprate and combine it with alkyl halide. So what will happen? This alkyl chain will combine with this alkyl chain and you will get the corresponding alkane being formed. So that's how the reaction takes place. Okay, as I said, you can prepare both odd and even chain alkanes by using the Curie-House synthesis. Okay, the last reaction for preparation of alkanes from alkyl halides is via the Grignard reagent reaction. Okay. If you have an alkyl halide and you react it with magnesium in dry ether, you will get Grignard reagent being formed. Now these Grignard reagents react with compounds having active hydrogen, including water. If you react it with water or you react it with alcohol, okay? So methyl group here and this hydrogen, sorry, ethyl group here and this hydrogen comes from here. So you will get ethane. So the alkyl halide by the Grignard reagent route has been converted into the corresponding alkane. By reaction, you can do the reaction either with water, you could also do the reaction with alcohol. If you are taking alcohol, only the side product will change. The side product in that case will be this. Okay? Correct? The next slide. The next method of preparation is from the carboxylic acids. I told you that the carboxylic acids can be converted into alkanes either by doing a decarboxylation reaction or by coal-based electrolysis. What is a decarboxylation reaction? If you have a sodium salt of carboxylic acid, sodium acetate here, and reacted with soda lime. What is soda lime? Soda lime is a 3:1 mixture of sodium hydroxide and calcium oxide. Okay, and heated to high temperature. the carboxylic acid will give you an alkane having one carbon less. That is what you have to remember here. Decarboxylation of carboxylic acids is used as a conventional step down reaction in the organic synthesis. Okay? Whenever you have to step down the homologous series, decrease the number of carbons by 1, you should think of this as one of the probable routes. All right. So for example, the example that I've taken here, sodium acetate on reaction with soda lime has given you methane, right? The next reaction is the coal-base electrolysis. Again, when you have a sodium salt of carboxylic acid and you subject it to electrolysis, what is the product obtained? Please forget about this COO minus. Remember only this alkyl group. This alkyl group will combine with itself and you get that product. That's how you can write the product, right? So, in case this alkyl group here is methyl, so you will get ethane as the product, right? And what is the mechanism of the reaction? The reaction proceeds through a free radical mechanism. For example, I have taken sodium acetate here. That's how the reaction takes place. The acetate ion will lose an electron to form the free radical. The free radical then loses a molecule of carbon dioxide to give you the alkyl free radical, and this alkyl free radical will then combine with itself, and then it will form the corresponding alkane. Okay? This mechanism I've already discussed. The next method of preparation of alkanes is from the carbonyl compounds, that is the aldehydes or the ketones, which can be reduced by using either Clemenson's reduction or by using Wolff-Kishner reduction. What is Clemenson's reduction? If you have a carbonyl compound, you reduce it with amalgamated zinc HCl, it will be reduced to the corresponding alkane. So what you have to do is you have to replace this C double bond O by CH2 and you get your product. Follow what I'm saying? This is Clemenson's reduction, and the Wolff-Kishner reduction may you can use hydrazine, ethanol, presence of KOH. Okay? That is the reducing agent. The product will remain the same. C double bond O being converted into the CH2 group. Okay? So that is how the aldehydes or ketones, they can be converted into the alkanes having same number of carbons. Follow me. So with that we finish with the methods of preparation of alkanes. Next is their chemical reactions. Now, I said in the beginning that alkanes are very less reactive. They do not show reactions under normal conditions of temperature and pressure. However, they are found to show some reactions taking place under higher temperature and pressure conditions. And those reactions we have categorized into 6 different categories. The first of those reactions is the free radical substitution. Next is the nitration reaction. Next is the sulfonation reaction. Then isomerization reaction. Then aromatization. And finally the pyrolysis. Okay? So I will come to these reactions one by one. Okay? The first reaction is the free radical substitution reaction. Alkanes combine with chlorine or bromine in presence of sunlight or at high temperature what will happen? One of these hydrogens is replaced by halogen. So there's a substitution taking place. But the reaction does not stop at the mono substitution stage. It is a chain reaction. It will go on to give you a poly substituted product. So if you're thinking of converting alkanes to alkyl halides as a method of preparation, it is not a very good method because you will get a mixture of products being formed in this case. Now, before I start this reaction, there are two things that we need to answer. And what is that? I said that this reaction takes place for chlorine and bromine. Why not for fluorine or iodine? In case of fluorines, normally fluoroalkanes, you do not prepare by direct fluorination reaction because the reactions are highly explosive. Okay, so is there any alternative method to prepare for fluoroalkanes? The answer is yes, no, and what is that method? Yeah, it is called the Schwarz reaction. Schwarz reaction mein you can use any inorganic fluoride and you react it with alkyl halide like chloroalkane. Right? And you can get the fluoroalkanes being formed by the indirect method. That is called the Schwarz reaction. Right? Now, how about iodination reaction? What one finds is when you do iodination, the reaction is actually reversible. Now, hydrogen iodide, which is formed as a byproduct, is a good reducing agent. It will get oxidized. It is a good reducing agent. So it will make the reaction go in the backward direction. The alkyl halide will be reduced back to alkane. Okay, so how do you do iodination reaction then? In that case, we add an oxidizing agent and that oxidizing agent will remove Hi from the reaction mixture. Okay, so what oxidizing agent we can add? We can add something like mercuric oxide, or you can add nitric acid, or you can add periodic acid. Okay, so what will happen? Mercuric oxide will react with Hi. Iodide, it will be converted into the mercuric iodide as the product. So Hi is being removed from the reaction mixture, so the reaction will move more in the forward direction. Right? Now, let us come to the chlorination or bromination reaction. When you are doing the reaction in sunlight, what will happen? What will be the mechanism of the reaction? You have a bromine free radical being generated. This bromine free radical will react with this, and what will you get? You get an ethyl free radical being formed. This ethyl free radical will further react with bromine, and what will happen? Right? So this is the chain initiation step. I said is a chain reaction. And these will be the propagation steps. And then this reaction will go further. Okay? So what will happen? You will get Huh? And then if you have sufficient amount of bromine, it can proceed further also, right? To the other carbon also, the reaction can proceed. And how does the termination take place? You can have bromine combining with bromine free radical to give you bromine. You can have the ethyl free radical combining with bromine free radical to form ethyl bromide, or you can have the ethyl free radical combining with itself, right? To form normal butane. Again, you get mixture of products being formed. Okay? Now, if you look at the order of reactivity of the halogen, it follows the order fluorine greater than chlorine, greater than bromine, greater than iodine, and the ease of replacement of the hydrogens is tertiary greater than secondary greater than primary. That means the tertiary hydrogen is most easily replaced. We have already discussed the mechanism. Okay. Now it looks very easy when you're talking of symmetrical alkanes. Like for example, here in case of ethane, all the hydrogens are equivalent. When I talk of an alkane where the hydrogens are not equivalent, then where does the free radical substitution go? Now here I have taken the case of normal butane. Now you can see that there are two different types of hydrogens which are present here. One is the primary the hydrogen attached to the primary carbon, and the other type of hydrogens are the hydrogens which are attached to the secondary carbon. Okay? So there are two different reactivities that we are looking at. When you react it with chlorine, you will get a mixture of products being formed. Now, how do you predict the major product? The major product here is the one where the hydrogen attached to the more substituted carbon is being replaced. This is the secondary carbon and this is the primary carbon. So the major product will be the one where the hydrogen attached to the secondary carbon is being replaced. Okay? Because I have already told you that the ease of replacement is tertiary greater than secondary greater than primary. So it is the intermediate stability which governs the if you are reacting it with chlorine free radical, what will happen? There are two different free radicals possible. One is this, when HCl is lost. The other one will be right. This is the secondary free radical and this is the primary free radical. The secondary free radical is more stable than the primary free radical, you know, because of hyperconjugation. Because of hyperconjugation, the secondary free radical is more stable than the primary free radical. So this will be the preferable intermediate being formed. So then this will further react with chlorine and you will get this as the major product. So whenever you are talking of free radical substitution on alkanes where there are different types of hydrogens, you have to first understand and locate the types of hydrogen which are present, plus the site of attack also depends upon the nature of halogen. You will find that in case of chlorine, the order of reactivity is for tertiary, secondary and primary hydrogen, it is 5:3.8:1. And for bromine, it is, that means in case of bromination, you will predominantly get a tertiary substituted product. But in case of chlorination, you will get a mixture of two where the tertiary substituted product will predominate. Understand what I'm saying? Because the reactivity of chlorine for tertiary hydrogen is more, so always a more substituted product will be obtained. Okay, in case of bromination, because it is very high for tertiary hydrogen, you will exclusively get tertiary substituted product. Okay. Next. That is the order of stability of free radicals, which I have shown here. The benzyl free radical is the most stable one, with stability nearly same as that of allyl free radical. Then the tertiary, then the secondary, and then the primary. And this order of stability, you know, is governed by the hyperconjugation, right? The next reaction is the nitration reaction. Now, this is nitration of alkanes is what we call the vapor phase nitration, which takes place at high temperature of 673 K, and it proceeds with the chain cleavage. Chain cleavage means it will give you a mixture of nitro products where the carbon-carbon bond goes on cleaving. So, for example, if you start with ethane, it will give you a nitro product corresponding to ethane, plus it will give you a nitro product corresponding to methane. So, you will get nitroethane as well as nitromethane being formed as the products. Okay? Again, it follows a free radical mechanism. The sulfonation reaction of alkanes again gives you a mixture of products, and the sulfonation will take place on all the different kinds of carbons which are present in an alkane. You can see here you have a primary carbon and you have a secondary carbon. So when the sulfonation takes place, you will get equal amounts of propane, 1 sulfonic acid, as well as propane, 2 sulfonic acid being formed as the product if you are starting with propane as the starting material. You follow me? All the different types of carbons will get sulfonated, and you will get equal amounts of all the sulfonated products being formed. Right? Next reaction. Next is the isomerization reaction. The isomerization reaction takes place with aluminium chloride in HCl on heating. So I have taken the example here. You see here how many carbons are there? This is a normal hexane molecule. So normal hexane molecule isomerizes to give you 2-methyl pentane as well as 3-methyl pentane. Okay? On heating. Reaction doesn't take place at room temperature. Please remember that. Okay? The next is the aromatization reaction. Now, alkanes having C6 to C8 carbons, when they are heated at high temperature in presence of oxides of chromium, vanadium, and molybdenum at 773 K, they have a property of cyclizing, number 1, dehydrogenating, hydrogen molecule will get lost, and aromatizing to the corresponding aromatic compound. Means if I start with hexane, a C6 molecule, I will get benzene. If I start with heptane, which is C7, I will get toluene. And if I start with octane, I will get a mixture of ortho, meta, and para xylenes being formed as the product. All right? The last reaction for alkanes is the pyrolysis. What is pyrolysis? Hydrocarbons, when you heat them to high temperature, they undergo thermal decomposition reaction, and that process is actually called cracking. Pyrolysis is thermal decomposition of any organic compound. Pyrolysis of hydrocarbons is called cracking. Okay? So what happens in cracking? When you're heating them to high temperatures, the carbon-carbon bonds will cleave. Because of the cleavage of the carbon-carbon bond, you will get a mixture of lower hydrocarbons being formed as the product. For example, if I start with propane, this bond will cleave. So I will get, one is ethane, methane. I will also get ethene if there is a dehydrogenation reaction taking place, right? So cleavage will give me lower hydrocarbons as the product. In case of propane, I've shown in the case of hexane also, you get a mixture of hexene, butene, ethane, ethene, propene and methane. So mixture of products are obtained. I think that's all we had to discuss in the first chapter on alkanes. Now I'm going to take up some problem questions based on what we have learned today. So please focus on the first question. It says 2-methyl butane reacts with bromine in presence of sunlight. Please see what will happen when 2-methyl butane. What will be the product obtained? What would be the correct answer? Locate the different, I said locate the different types of hydrogens you have. You have a methyl, you have a secondary carbon, and you have a hydrogen attached to a tertiary carbon. Now remember, I told you in case of bromination reaction is exclusive for a tertiary product. So the tertiary hydrogen will be replaced and the major product will be so this will be 2-bromo, 2-methyl butane, and that will be option number B. Right? Okay. Let us go to the next reaction. An alkyl bromide reacts with sodium in ether to form 4,5-diethyl octane. This is what I was talking about. Four, 5-diethyl. Right? That will be the compound. So I told you when we were discussing what reaction is this? This reaction is the Würtz reaction, right? So divide the molecule at the center and combine those carbons with halogen. Where is the center? This is the center. And combine it to halogen and that will be a product. The starting material will be that will be the starting compound, right? And what is that option? Option ये वाला है ना, option D, right? That will be the correct option. So next question is alkyl halides react with dialkyl copper reagents. What is this reaction? Alkyl halides reacting with dialkyl copper reagents? Kuhle-House synthesis. And this is used to prepare what? Prepare alkanes, right? So the correct option will be C, right? The next reaction is of the 5 isomers of hexane, the isomer which can give you 2 monochlorinated compounds. See, Write the isomers of hexane. And again identify number of different types of hydrogens which are present. And see where you have only 2 types of hydrogens being present. So you can write the product. Please write. Jaldi se likho. 1, 2, 3. This is normal hexane, right? So how many different types of hydrogens you have? One will be this, one will be this, and one will be this. Okay? So you will get 3 different types of products. So it cannot be an hexane. Correct or not? You have to see number of types of hydrogen because ये तो equivalent होगा ना positions. This position is equivalent to this position. This position is equivalent to this position. Okay? So you have 3 different types of hydrogens being present. So you will get 3 different products. What about the second one? Yeah. So how many different types of hydrogens are present here? There are 2 types of hydrogens. One is this, these are equivalent, right? And one is this. Again, both these are equivalent. So you have 2 different types of hydrogens. So the correct answer will be B. 2,3-dimethyl butane. Correct? Let's go on to the 6th question. 5th करना है? चलो करें. वो easy लगा था, that's why I'm not doing it. Ethane is formed by reaction of methyl iodide with sodium methyl. This reaction is known as easy. Ethane is formed by reaction of methyl iodide with sodium methyl. What's reaction? Right? Next question. Which one of the following cannot be prepared by Wurtz reaction? CH4 भी नहीं prepare हो सकता and C3H8 also cannot be prepared. This question actually has 2 correct answers. Okay. Next. Next is question number 7. This compound on Wurtz reaction forms this hexane as the main product. Now this you can do very quickly. Wurtz reaction hai, please locate the center and write the structure of the starting compound. Please do it and tell me what will be the product or the starting material. Two 2,2,5,5 tetramethyl hexane. Write the product. That is it. This is it. 2,2,5,5 tetramethyl hexane. So cut it at the center. And that will be your starting material. Okay? 2,2-dimethyl, 1 chloropropane. Correct? Now the similar type of question we have 8. You should be able to do it quickly. There is a compound having C8 carbons on chlorination. It is giving you only monochlorinated product, only 1 chlorination product. That means only all the hydrogens are equivalent. That means please look for that compound where all the hydrogens will be equivalent. What will be that option? The answer carefully you have to see. It is not B. B mein there are so many types. A also there are so many types of hydrogen. You see here there are 2 methyls here. There is 1 methyl here. There is 1 carbon here. C bhi nahi hai. That is the option left actually, na? See how D? Why D? No. So organic chemistry appears very easy when we are writing reactions. When you come to solving question, it becomes very difficult. So you have to apply the concept, right? So there are, Can you see here? All the three here and all the three here. There are equivalent. So only one possible chlorination product. Okay. Okay. The correct answer is D. Chalo. The next reaction is you have this compound. You reacted with magnesium in ether, okay, and followed by reaction with D2O. You are getting some compound. This, when reacted with sodium in ether, you have to predict the product. Grignard reagent reaction. So where will the Grignard reagent reaction take place? उसके बाद क्या रिएक्शन है? Wurtz reaction. ठीक है? So this carbon having halogen and the other carbon having halogen will combine with one another. So what will be the product? That is the product you will get. ठीक है ना? The cyclobutane. So the two carbons will get linked to one another. ठीक? That is the product. The next reaction is there is a compound having molecular formula sharp नहीं हो रहा ना? Heavy water, not hard water, heavy water. D2O, D2O. हाइड्रोजन को ड्यूटेरियम से रिप्लेस किया है ना? अब ठीक है, पहले शार्प नहीं हो रहा था. Now there is this compound C6H12 which has chirality, but on hydrogenation it is converted into C6H14 compound where the chirality disappears. ठीक है? So you have to find out what is A. Please write the structure and see. This is the first molecule, 3-methyl-1-pentene. Right? What will happen when you do hydrogenation here? Is it chiral? It is chiral or not? There is a chiral center here, so the molecule is chiral, right? Now what will happen when you do hydrogenation here? Easy है, इसमें कुछ भी नहीं है. See, बोलो. Isomerism तुमने स्टीरियोकेमिस्ट्री किया है ना जनरल कॉन्सेप्ट्स में? A chiral carbon is the one which has 4 different atoms or groups of atoms attached to it. Optical activity नहीं करवाया? कोई बात नहीं. So when you have a carbon which has 4 different groups attached to it, it is called a chiral carbon, and that compound will be optically active because of the presence of chirality in the molecule. ठीक है? And then it will exist up as a pair of enantiomers, है ना? It will exhibit enantiomerism as a pair of mirror images. This is a chiral carbon because there are 4 different groups attached to it. ठीक है? Now when you do hydrogenation, what will happen? Will it still be chiral? Is it still chiral? It is not chiral now because there are two similar groups attached to it. Okay, na? So the correct answer will be, this is the first molecule which we wrote, no? The correct answer will be A. Because on hydrogenation, it is converted into a molecule which is achiral. There is no longer chirality present in the molecule. So it will not exhibit optical isomerism. Okay? Right? Next. What will be the product formed when 1-bromo-3-chlorocyclobutane reacts with 2 equivalents of sodium metal? 1-bromo-3-chloro. Cyclobutane. What reaction is this? What reaction is this? Huh? Wurtz reaction. If it is a Wurtz reaction, what will happen? It proceeds through formation of free radicals. If you have a free radical being formed, different people have different ways of pronouncing things. For me, it is Wurtz reaction. आपने Wurtz reaction किया है, ठीक है? ठीक है? However you pronounce. So you will have a diradical being generated like this. Once you have a diradical being generated, the two carbons will combine and that is the product you will get. What is the option? Option number D. ठीक है? देखो, if you have an alkyl halide and you are reacting it with sodium, ठीक है? How does the reaction take place? Sodium will ionize to give you sodium ion and electron. ठीक है? This alkyl halide will combine with electron and it will give you R free radical and X minus. So basically in the Wurtz reaction what happens is you have a free radical being generated at the center where it was attached to halogen. So that's what I have done. If you have this, the centers which were joined to halogens will now get a radical center being generated. Once the radical center is generated on these positions, these two carbons will join to each other. Okay? And you will get this product being formed. Correct? Okay. The next reaction is, if you see this, there is a bromine free radical combining with this hydrocarbon. They are asking you to predict what free radical will be generated. That means again you have to locate what hydrogen is going to be replaced. Please tell me, where will the hydrogen be replaced in this molecule? The correct answer will be, it will be B, because that is a tertiary hydrogen, right? Attached to a tertiary carbon, that will be replaced and you will get this P as the product. Okay? Next, which one of the following alkanes has the highest boiling point? If you look at this series here, it will be N-hexane, because that has the maximum number of carbons and the straight chain molecule, right? Okay. The next is to convert a methyl iodide to normal butane. How will you convert methyl iodide to normal butane? Can you think how you are going to do this conversion? See, Do the both reaction and you will get a 2-carbon chain being formed. Now please remember, free radical substitution is not a very good method to prepare alkyl halides. I told you, unless all the hydrogens are equivalent, because in this case you will get only one mono-substituted product being formed, right? हो गया? And one more time. Okay, so you have normal butane being formed. Take. The next question is, why the carbon-carbon bond and not the carbon-hydrogen bond breaks during cracking? I have given you the values of the CC bond and the CH bond also. So the answer is there in front of you. The CC bond will require smaller energy to break. That is why it is easier to break. That's why it breaks, right? What happens when butanoic acid is heated with soda lime? This is easy, quickly write. What happens? You will get propane being formed as the product. The second part is a little tricky. Is there any other acid which can give you the same product? Besides normal butanoic acid, is there any other carboxylic acid which can give you N-propane on decarboxylation? Think about it. What is this compound? 2-methyl sodium propionate. So it will undergo decarboxylation reaction and you will get N-propane as the product. ठीक है जी? All right. Okay. The next this question is easy. This I think you can do yourself. You have to give a suitable method to synthesize propane in the lab. And what will be that method? To synthesize propane in the lab? Hydrogenation you can do. You can start with propene. You can do hydrogenation. Very good. Any other? One more. Curie-House synthesis. Odd number of carbons hai, you can use Curie-House synthesis, right? Started with ethyl bromide and combine it then with methyl bromide in the end, right? Okay. The next question is, what is the effect of branching on the melting point of the organic compound? If I take the example of I have 3 isomers for you. One is normal hexane, okay? Normal pentane, sorry, isopentane, and the third one is neopentane. Which one amongst the 3 will have the highest melting point? Remember, the symmetrical molecules fit better in the crystal lattice, so they have higher melting points. Neopentane is a symmetrical molecule, so it will have the highest melting point amongst the 3 isomers, followed by N-pentane and then the isopentane. Okay, so that will be the order of melting point of the 3 isomeric pentanes. Okay, I think we will stop with alkanes here and I will take up alkenes now. Next slide. Next presentation. So what we'll do is, we will do the methods of preparation of alkenes today, the reactions of alkenes, and the alkyne chemistry we will discuss tomorrow. Okay. Alkenes we have already discussed. They are unsaturated hydrocarbons which have at least one carbon-carbon double bond. They have a general formula of CnH2n, and if they are cyclic, they will have a general formula of CnH2n minus 2. Right? They are called olefins, the word coming from the Greek word olefiant, which means oil forming, because they combine with chlorine or bromine to form oily substances. Right? The structure of alkene, if we look at the simplest member of the family, that is ethylene, the carbon is sp2 hybridized, the 3 sp2 hybridized orbitals occupying 3 corners of an equilateral triangle, and one of the sp2 hybridized orbital on carbon overlaps with the sp2 hybridized orbital on the adjoining carbon to form a sigma bond. The remaining 2 sp2 hybridized orbital on the carbons will be utilized in formation of sigma bond with hydrogen. You have one pure p orbital which is left on each of these carbons, which will undergo a lateral overlap to form the pi bond. Right? The bond length of the carbon-carbon bond is 1.34 angstrom. The bond length of the carbon-hydrogen bond is 1.10 angstrom, and the bond angle is about 116.6 degrees in case of ethylene. Okay. Some of the common homologues in this family are propene, butene, which exists in the 3 isomeric forms, 1-butene, 2-butene, and then the isobutene. Okay. As far as their physical properties are concerned, being again not weakly polar compounds, their physical properties will be very similar to those of alkanes. Okay. They will be water insoluble. The melting point and boiling points will follow more or less the same trend as we have discussed for the case of alkanes. And of course, because they are a non-polar compound, there are no hydrogen bond formation possibility. What are their applications? Ethylene is used in ripening of artificial ripening of fruits. Number 1. Polythene we all use. We are not supposed to use, not environment friendly, but we are still, all of us are using. Used to make shopping bags, your buckets, bottles, they are all made from polythenes, not biodegradable. Few days back, Japanese scientists, they have identified one enzyme, and that enzyme, is known to eat away plastic. So they are in the process of developing that technology. So if that technology comes, then we can use plastics. Huh? The next is polypropenes. Polypropenes which are used to make milk crates, carpet fibers. And then polystyrene which is used for insulation, for packing, and for making ball pens. Okay. There are methods of preparation. 5 different methods of preparation that we are going to discuss for alkenes. The first one is from the alkynes by hydrogenation reaction. Next is from alkyl halides by what we call the dehydrohalogenation or the elimination reaction. Next is from vicinal dihalides by dehalogenation reaction. Next is from alcohols by a dehydration reaction. And finally, from the sodium salts of carboxylic acids by coal-based electrolysis, which we have already learned, in case of alkanes. Okay. Let us start with the first reaction from alkynes. Now, I told you when we were discussing the methods of preparation of alkanes that alkenes add on 1 molecule of hydrogen to form alkanes, whereas alkynes, they add on 2 molecules of hydrogen to form alkane. Now, if you have to stop the reduction at the alkene stage. That means you have to carry out a controlled reduction. So you have to control the reduction so that it is not proceeding beyond the alkene stage. That can be done by using two different types of catalysts. The first of those catalysts is the Lindlar's catalyst. What is Lindlar's catalyst? Lindlar's catalyst is hydrogen in presence of palladium, which is precipitated on barium sulfate or calcium carbonate, and it is poisoned with either sulfur or quinoline. How does the poisoning help? The poisoning helps in controlling the reduction at the alkene stage. Very importantly, by doing a controlled reduction of alkynes, we can control the stereochemistry of the product which is being formed. Meaning, if you start with Lindlar's catalyst, you will get a cis alkene being formed as a product. Whereas, if you do a Birch reduction, you will get a trans alkene being formed as a product. So if you have to convert an alkyne into a cis alkene, do a Lindlar's catalyst reduction. And if you have to convert it into a trans alkene, use a Birch reduction. Okay? So by choosing a suitable reagent, we can control the stereochemistry of the product which is to be formed. One example I have given you here, butane on catalytic reduction, giving you butene here. Now this example I have taken here, for example, see here, I said if you are doing a Lindlar's catalyst reduction on an alkyne, you are getting a cis alkene as a product, and when you are using Birch reduction, you are getting trans alkene being formed as a product. Okay. Next is from alkyl halides. Now, alkyl halides undergo a dehydrohalogenation reaction where hydrogen and carbon have to be lost from the adjacent carbons. Okay? It is an elimination reaction which takes place in presence of strong bases like alcoholic KOH. So one hydrogen and one halogen lost from the adjoining carbon, and you get the corresponding alkene being formed as the product. Okay? The order of elimination of halogen is iodine greater than bromine greater than chlorine, and the ease of loss of hydrogen follows the order tertiary greater than secondary greater than primary. One more thing you have to remember when you're talking of elimination reaction of alkyl halides, that these reactions are subjected to isotope effect. Means hydrogen is abstracted more easily being the lighter isotope as compared to deuterium. Okay? Now I've given you some examples here. If you have 2 bromopropane, if you see, 1 bromine and 1 hydrogen has to be lost from adjacent carbons. Now in this case, both the sides, the hydrogens are equivalent. So there is no problem. Hydrogen can be lost from the right side or the left side. You will get the same product being formed. Normal propene will be formed as the product. Okay? Similarly, in case of butyl bromide, N-butyl bromide, again there is only one type of adjacent hydrogen. So only one particular product can be formed. But the problem comes when you have more than one type of replaceable hydrogens, as is the case here. You have a, a hydrogen attached to a primary carbon here, and you have a hydrogen attached to a secondary carbon here. Okay? So when the dehydrohalogenation reaction takes place in this compound, that is secondary butyl bromide that I have taken here, let us mark this hydrogen as A and mark this hydrogen as B. When A is being lost, the product obtained will be 1 butene, right? And when B is lost, the product formed will be 2 butane. So which is the major product? The elimination reaction of alkyl halides follow what we call the Cbse's rule. What does the Cbse rule say? Cbse rule says the more stable alkene is the one which is more substituted. If you see here, this alkene, on the olefinic carbon, there is one alkyl group on the other side. Okay, whereas here, there is only one alkyl group this side, there are only hydrogens on the other side. Right? This is one alkene, just less substituted as compared to two alkene. So because this is more stable, so this will be the major product. Okay? So in the dehydrohalogenation reaction of alkyl halides, you have to remember that the product will be governed by the Cbse rule. The major product will be the more substituted alkene always. Okay? What is the mechanism of the elimination reaction? The mechanism of elimination so if you have the base, it's a bimolecular elimination reaction. Giving you the corresponding alkene as the product. Now please see at the bottom, I have given you the order of stability of alkenes. This is very, very important. If you see, tetra substituted alkene is the most stable and ethylene is the least stable alkene. The stability of these alkenes is determined by their heats of hydrogenation. Higher is the heat of hydrogenation, lesser is the stability of the alkene. Is that okay? Heats of hydrogenation means what? How much energy is given out when they are hydrogenated. Okay? Next is their method of preparation is from vicinal dihalides. What are vicinal dihalides? Where the halogens are occupying adjacent carbons. The vicinal dihalides undergo a dehalogenation reaction when reacted with zinc to form the corresponding alkene. So halogens will be lost from adjacent carbon and you will get the corresponding alkene as the product. But please remember, these vicinal dihalides, they are prepared from alkenes. Okay? So vicinal dihalides do not offer a very good method of preparation of alkenes because they are prepared from alkenes. Right? So, but this route can be used as a very important route for purification of alkenes. If you have a mixture of alkane and an alkene, you react it with chlorine, what will happen? So if you have a mixture of ethane and ethene, or a butane and a butene, and you are asked to separate them, what will you do? You add bromine to this, okay? The bromo derivative gets precipitated, you separate it, and then you react with zinc, dehalogenation reaction, and you get back. So it can be used as a method to do purification of alkenes rather than for preparation. Okay? The next method of preparation is from alcohols. Alcohols can be dehydrated to alkenes, the reaction being catalyzed by strong acids like concentrated sulfuric acid, phosphoric acid, or by using alumina as the dehydrating agent. Again, like in dehydrohalogenation reaction, you have H and OH being lost from the adjacent carbons to give you a carbon-carbon double bond. But please remember, this reaction proceeds through the intermediate formation of carbocations. So whenever you have a reaction proceeding through the formation of carbocations, invariably some rearrangement can take place. So alcohol to alkene will not be again a very good route to prepare alkenes, because you can have rearrangement taking place because of the intermediate formation of carbocation. Let us see the mechanism of this reaction. In the next slide. So the first step will be protonation. Protonation will take place. Okay. Followed by loss of a molecule of water, and you will get a carbocation being formed. Now this carbocation is a primary carbocation, not very stable. If you look at the starting material, and if I don't understand the concepts of carbocation chemistry, I will say the product will be this. Okay, because I am saying there is hydrogen and the OH to be lost from adjacent carbons. So this hydrogen and this OH will lose, and this should be the product. But what happens is, the moment you have carbocation being formed, you will have a 1,2 shift taking place. So what will move? You will have a methyl shift taking place. Huh? The migratory aptitude is methyl better than hydrogen. Okay. So here you get this, and one hydrogen will be lost. This was a primary carbocation, and what do you get here? Now a secondary carbocation being formed, right? And then proton will be lost from this carbon, and you will get, what is the product? The product obtained will be 2-butene, right? Instead of the expected isobutene. Okay. So please remember, the order of reactivity of alcohols is tertiary greater than secondary greater than primary. The dehydration will take place in presence of acid catalyst. There will be rearrangements taking place if the carbocation is not stable. And because the rearrangement are taking place, you will get a mixture of products being formed. That is why the dehydration of alcohols is not a very good method to prepare alkenes. Okay? I think that is all for today. We will continue with the remaining reactions tomorrow. Okay?